All right, we thought the parts were done, but remember I said they may not actually be done. Well, that turns out to be the case. They are not actually done because I shipped them to the vendor. Noticeably, I screwed up. I don't know, I had these big Sharpie marks all over this thing, and somehow I marked some of these wrong. This says stainless steel on it. It's the Inconel. The only thing I think of is in the damn software, you've got all these options, and down below is the text. You change the text, it changes on the screen, but if you don't hit apply, the moment you hit the engrave, it shifts back if you didn't hit apply. And the apply is like mixed in with all these other buttons. It doesn't even stand out. That's my fault, but really poorly done software. So these are incorrectly engraved, and I'm gonna have to fix that. Also, so this guy here lines up, and I left slop here because you're welding the outside of the parts. And if you're remembering, these discs fit on here and stick out 10 thousandths. Well, first of all, 10 thousandths turns out to not be enough. They decided, well, maybe it needs to be 20 thousandths size. So we need to take another 10 thousandths off of each one of these. However, next problem. So I was not relying on that center pin to locate, so I made this hole oversized on purpose. Well, it turns out, live center, not on center. So if I was counting on this lining up and getting everything in line, I can't anymore because their live centers apparently get knocked out very easily, and they're really a pain to put back, so they try not to rely on it. So instead, we're gonna have to make this pin stick out more and find a counter relief that it'll sink into in the top, and that'll line both these parts. So I need to remove some outer diameter from both of these, make this taller, face this off, and make another place for this part to fit into that's precise, that matches that side with a slip fit. Okay, this one, again, 10 thousandths, not enough clearance. They decided they wanted 20 thousandths after seeing the part. They're bringing the laser in from as close to flat as possible, so I might change this chamfer as well to an even shallower chamfer so they can get their laser more of an angle. They're also worried about the disc sitting on here being supported. Remember, this was just to push down on the two discs and hold them together so they can weld the inside. Well, see on this part, when they weld the outside, that's step one. Well, it's really step two. First the needle goes on, but we're ignoring the needle part. So when they weld this outside portion here, it's going to reduce the diameter because they're not adding material, they're just using the material itself to weld. So it's going to shrink, and they don't know how much. So this, which is a good fit now, may not be a good fit then. So what they need is this hole opened up another 10 thousandths aside. They need a relief. Oh, and then they think that the discs, if they're being welded sitting on top of here, that even though they're coming in an angle and trying to hit right at the junction between the two discs, they're worried about it welding to the base. So they want relief larger than this internal diameter here on the base. But then how do you locate the part that you can't trust with the outer diameter anymore? So what we're going to do is we're going to create a tool that will neatly fit in here that will locate these parts on the central diameter. So all those changes we need to make. One of them was definitely my fault. The mislabeling of the engraving on this, I still feel horrible about that. And the rest are changes they made after the fact. So let's just get started. All right, so first step is going to be reduce this diameter. Except that is not sitting in there. I'm going to have to dial this guy back in. I can tell that that is not sitting on center. Wow, that's quite a lot of run out. Okay, I got it within 1/1000th. That should be fine. This is not a super precision anything. Better than the 5/1000ths I was going out before. Take 20/1000ths off. All right, so next up, we're gonna make this guy stand out a bunch more. So I left this a little large on purpose so I could bring it down to final size. That should still be a little bit more. It's very hard to measure this. Okay, that is a really keen fit. And that still doesn't leave, well, I actually have 4 of these on here. So, should have 2. That probably leaves enough material. Well, maybe we'll do another 25/1000ths. Okay, I think that should be it after I deburr it. It's actually not too sharp. This is pretty sharp. That looks good. And I can feel this edge all the way around. Part 1 done, except I've got to re-chamfer that hole. Next part, I got to face this off. Hopefully there's enough material under there to have a mating part. Otherwise I have to remake this from scratch, which is a lot of work. So I hope that's not going to be the case. That's good, within 1/1000th. Plenty good. Gonna fix the outside first. And we facing off all of the existing material where the hole is, because the new hole is going to be much smaller in diameter. Okay. Now we need to put a new divot in there that will fit 0.945, I believe is the number. I'm going to start with a 3/4 inch hole. Once I see those edge flutes start touching, hopefully this won't chatter too much. There we go. So we're going to go 75 thousandths. Okay, that should be good. That should be pretty close to 3/4 of an inch. Now we just need to bore it out to size. We're shooting for 0.944. We're currently at 0.753. This should be 0.9 on the money. Okay, it's a little bit off. Okay, let's see if this works out to 0.925. So this should be 0.925, trying to make my DRO match my measured readings. Yep, that's really good. All right, so we're shooting for 0.944 with like a thousandth over, so we'll just do 0.945. That hopefully will give enough. Might have to take off a little bit more than that, but let's try 0.945. Here's a test fit. Very nice. Good side to side. $20 thousandths really is not much material, but definitely can feel it. I mean, it would catch my finger on it completely, but holy cow, that is not a lot. All right, first pair done. Doing the outer diameter of set number 2 for the same parts. Here's the second one for Inconel. Oops. There we go. That's a really tight fit. I mean, it's a sliding fit, but yeah, there's a tiny bit of wiggle. Tiny. Yeah, perfect. Okay, these guys are done. All right, here we are on the Inconel part, starting the first one of these. Since I had the paperwork over here, I'm going to reface this off. Then take this corner out, this edge off. We need to bore out the middle to be 20 thousandths larger. This was easier before I chamfered it, of course. There we go. I think we just hit it. All right, so 20 thousandths bigger. Okay. And then we need to change the chamfer. They also wanted this angle shallower. So I made it 15 degrees. Jeez Louise. Okay, there we go. That's a lot shallower because remember, they want to take the laser as close to horizontal as possible. That is a very shallow angle, 15 degrees. So this part is done. And this center part, we need this diameter fairly accurately. No, we don't. No, we need the other side pretty accurate. Okay, we'll do the second half of this and go from there. So this hole will perform two functions. One, it will be accurate enough that we can fit a small piece inside that will help align the discs to the center of this, since we can't rely on their outer section anymore. So, and the second thing is going to be to provide relief. So the top, maybe 100 thousandths of an inch, is going to be just a section of relief that'll be larger diameter than the discs themselves, so that there'll be no chance they'll weld. So I need it just like maybe 50 thousandths larger kind of thing. We'll see. First we need to bore out the center. Okay, I think that's about the limit we can do with this guy. Using an end mill to cut a hole is not what they were made for like that, but they certainly work. Next thing is we need to relieve the top section here to just over 0.991. So 0.991 plus at least 40 thousandths. Yeah, plus at least 40 thousandths. Okay, so that would be 1.031. Okay. I think that part's done. So then we need to create a pin that fits down the center of this that's the exact diameter of those rings. That'll mate with this 3/4 section in the middle. Slightly larger on the outside to mate with the pins, which are 0.991 in diameter. Next up, we're going to make the pin. I'm going to face this off. This is a pretty nasty looking piece of material. I probably should have just saw cut it, but we're here now. So there's not going to be a lot of material to come off of here. I need to know where we're starting. So we're shooting for, it's supposed to be 1-inch material. Looks like it's 1.002. And it's circular, that's nice. Go for the large diameter first. So we're looking for .991. All right, let's test this to see if that's right. This should line up with this pretty well. That's a little too tight. Probably could get that on there, but that's plenty. Let's see if this fits. Oof. Still too tight. Huh. That was only 1,000 more, 2,000 more. Went from super tight to, this first section does not matter, by the way, because that's going to be reduced down to 3/4 of an inch. $900, $850. How's our fit now? Huh. Oh, yep. There we go. Oh, that looks, oh, that's nice. Okay, perfect. This way you can slip the rings over from the top if you want. And we'll just part this guy off. Okay, there's this guy. So drop the alignment pin in. You can see that it's got relief around it, which says that these have relief around it. Slide the washers down. Pop this guy over the top, pull this out, weld away, and that will center the washers, should center the washers right in the middle. Hold this down, lift it up, and they are centered. So even if they're smaller diameter than the inside diameter of this, they should still be centered. Good to go. One more. All right, there's the alignment pin. Drop these guys down on top of it. Drop this guy here, pull the pin out, weld away. And it's hard to see in this light, but there's a 20,000ths aside amount of material sticking out, and I changed the relief to be 30 degrees. All right, we find ourselves here at the end again. I have re-engraved all of the parts, made a couple new ones, a locating pin, and I simplified the language I put on it. The first one was too complicated, and I double checked. I just did them all at once. I didn't bother identifying, you know, individual parts separately. That didn't seem necessary. There's all 50mm Inconel or 1.96 inch stainless steel. Hopefully that'll be enough for them to figure out what's going on. So we are done. We will ship this back and hopefully they will like it. Thanks for watching. Hope you enjoyed it. Hope to see you next time.